Here's our second part of our 3.1 video. We learned in the last video how to convert from slope-intercept to standard form by putting both x and y on the same side and realizing that the a value has to be positive and it can't be a fraction. So let's use what we learned in that last video. Hopefully you still have your notes. And let's look at some graphs. So first we're gonna have to put these equations in slope-intercept form and then convert to standard form from there. So you're always wanting to start with that slope-intercept form. You could also start with point-slope form, but right now we're just focusing on slope-intercept. So that means we need to identify both the y-intercept or the b value in the slope, which is the rise over run. To do that, I need to identify a couple points. I'm gonna have my y-intercept be one of them, so I look where it crosses the y-axis. I see that's at -5. And now I'm gonna find another point. Looks like I don't really have another point until we get way up here. So now I need to count my rise over run. I go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 1, 2, 3. So we went up 10 to the right 3. My slope should be a positive 10 over 3. Now using these two numbers, I can write my equation in slope-intercept form, just plugging in the m and the b. M and the b. So y equals 10/3 x minus 5. We're halfway there. We're in slope-intercept form. Now we need to convert to standard form. So I'm just going to write it down here again. Okay, and the first thing I need to realize is, we have a fraction. We have a fraction for our a value. So I'm going to multiply by the denominator, which is 3, which is going to mean I have 3y equals 10x minus 15. Okay, now let's put the x and the y on the same side. I'm going to subtract by 10x on both sides. Now it's not over here, and I have negative 10x plus 3y equals negative 15. Oh no, I have a negative a value. Negative a. So I need to multiply by -1. Everything by -1. And then when I do that, it's going to be 10x minus 3y equals 15. That's my final answer. I could write it right there, but I have it already nice and pretty, so we're going to leave it there. That's the equation of the line. It's the exact same thing as y equals 10/3 x minus 5, just written in a different form. But that is still the equation of that line up there in the graph on number 3. All right, let's look at example number 4. Again, we're going to have to identify the y-intercept and then a point. So I found a point right here. Doesn't matter where your 2 points are, guys. Okay, this is just like finding slope from a graph. Same idea. My y-intercept is -1. And my 1, 2, 3, down 3. I also can see that my slope is negative. I'm going to go ahead and put a negative so I don't forget. It's over 1, 2, 3, 4, 5. So my slope is 3 over 5. I can write that in slope-intercept form, just plugging in my m and my b where they belong. And now that I have that, I can start converting. So from y equals -3/5 x minus 1, I once again have a fraction. So I'm going to multiply by that denominator. This time it's 5. Remember, denominator is the bottom number in the fraction. So 5 times y is 5y. 5 times -3/5 is -3. You're only left with the numerator there, okay? And you can plug that into your calculator, guys, if just the fraction and the number. 5 times -3/5, and you'll get -3. And then minus 5. Add my ax to each side, because it was negative already. And I have 3x plus 5y equals -5. My a value is positive, so that's my final answer. Let's try one more example here. It's a little bit more of a word problem. It says write the equation in both slope-intercept form and in standard form. Okay, we're looking at temperatures, degrees Celsius compared to degrees Fahrenheit. So let's go ahead and identify our y-intercept and our slope. I see the y-intercept where it starts is at 32. So that's going to be my y-intercept. And my slope, I need to find another point, so I'm going to find a nice and pretty point. There, I found one. Ooh, but I'm counting by weird numbers here. That honestly seems kind of difficult. What I think I'm going to do is find the ordered pairs for my 2 points and maybe make a tiny table or plug them into my calculator to find slope, because I don't want to make a mistake counting rise over run here. 40, 104. Okay, this is perfectly okay to do, guys. You don't have to count rise over run. And now that I've done that, I can plug it in or make a tiny table. If I'm plugging it into the equation, that's my y2 minus y1 over x2 minus x1. But you do however you want to find slope. Then I'm going to do 104 minus 32 divided by 40 minus 0. And that's going to give me what my slope is if I just type that into the calculator. When I type that into my calculator, I get a slope of 9/5. So now I have an equation in slope-intercept form that is y equals 9/5 x plus 32. Same idea now. We're going to take that very equation and convert it to standard form. We're going to multiply by the denominator. That's going to get me 5y equals 9x plus whatever 5 times 32 is, 160. And then I'm going to move 9x to the other side. So we have negative 9x plus 5y equals 160. Oh no, I have a negative a. Negative a right there. So I'm going to multiply everything by -1 so that I have 9x minus 5y equals negative 160. And guys, that is going to be my final answer in standard form. All right, let your teacher know if you have any questions. But the basics, can you find slope and identify the y-intercept? And if you can do those two things, then you can write in slope-intercept form where the slope is m and the y-intercept is b. From there, it's all about getting x and y on the same sides to convert to standard form. So make sure that you don't have a fraction by multiplying by the denominator if applicable, and then subtract or add the opposite of whatever my a value is, meaning if it's positive, subtract, and if it's negative, add, and then make sure that it is ending up, when it's on the same side as the y, the by value, that it is positive. And if not, multiply by -1 to make it positive. All right, let your teacher know if you have any questions.